In this video, we're going to take a look at similar polygons. What does it mean for two polygons to be similar? How can we tell if they're similar? And if we do know they're similar, how can we find an unknown? So we'll be addressing all those things today. So let's first actually get two polygons on our page that are similar, and then we'll talk about them. Okay, so here we have two polygons, and you may notice that this one looks a little smaller than this one. So two similar polygons don't necessarily have to be the same size, but they do have to have the same shape. So they can be entirely different sizes, but, must have the same shape. All right, so if they have the same shape, then what's definitely going to happen in here is that our angles, corresponding angles, will be congruent. So angle O, oh, that's supposed to be, let's try that again. Angle O will be congruent to angle Z in this case. Angle L will be congruent to angle W in this case. Angle M will be congruent to angle X in this case, and angle N will be congruent to angle Y. Now there's something important about the corresponding angles. So here, as we just looked at, we know that O is corresponding to Z, L is corresponding to W, and so on and so forth. So if I name my first polygon L, M, N, O, so I named it in this order. I started at L and I went L, M, N, O. I have to make sure I do the same order when I'm calling this, when I'm naming this polygon. So I would say L, M, N, O is similar to, and that's the is similar to symbol. And so that is similar to W, X, Y, Z. And it's not because the letters are in order alphabetically, it's only because I'm listing corresponding vertices in order. So L is corresponding to W, M is corresponding to X, so on and so forth. So when you write that two polygons are similar, that's how you would write it down. Okay, so as we already discussed, we know that these polygons do not have to be the same size, but the corresponding sides must be proportional to each other. I'll repeat, the corresponding sides must be proportional to each other. What do I mean by that? All right, well, let's first look at LM and the side corresponding to LM, so WX. So if I take LM and I put it over WX, you'll get the same fraction as if you take MN and put it over XY. So that's going to give you the same thing as MN over XY. And if these polygons are in fact similar, I could go again and I would get the same fraction if I put YZ over NO. And I could go one more time and I could say, well, how about these two guys right here? Well, you're going to get the same result if you put OL over, let's see, ZW. Okay, so all these fractions will be equivalent to each other. So that's what it means when we say that our corresponding sides are proportional. All right, so let's look at an actual example with numbers, and this will become so much clearer. Okay, so in this example, we know that we have two similar polygons. We know they're similar because it says it right here. It says ACDF is similar, that's what that means, to VWYZ. All right, so now that we know they're similar, that's not actually enough. We also need to know what sides are corresponding to each other. And we can tell what sides are corresponding not just by the way the polygons look, but also by the order in which these letters are listed. So for example, our two first letters, AC, and our two first letters, VW, are corresponding to each other because they're the two first letters in both cases, which means that we could have a ratio AC over VW, which would give us an important number, which I'll mention in a second. But that number is also going to be equal to, and I'm going to switch colors here, the second and third letter here is corresponding to the second and third letter here. So that number will also be equal to CD over WY. And I could go ahead and do that again. Let's switch the colors. The last two letters here, the last two letters here. So that will be equal to DF over YZ. And then I could keep going. I could close it off and say that that is equal to FA over ZV. Alright, so these are all pairs of corresponding sides. When we divide each and every one, we should get the same number. That number is called the scale factor. So the scale factor is consistent throughout. The scale factor will always be equal to the scale factor, right? So how do I use this to figure out what x is? Well, we don't have every piece of information here, and there's certain pieces of information that are more useful than others in this case. We do have CD, which is corresponding to this one here, WY. So because we have two corresponding sides, we can definitely use that. So let's go ahead and set that up. CD is 9 over WY, which is 6, is equal to, and we're trying to find DF, so we can say it's equal to DF, which we don't know. All we know is that it is X. So far, that's all we know. Over YZ, but we do know YZ, which is 10. Alright, so now we've set up a proportion, and all we have to do is solve it, and that's actually the easier part. So now we can cross multiply, and when you multiply these two numbers, we get 6x equals, and when you multiply these two numbers, you get 90. Now to isolate the x, we just have to divide both sides by 6 so that we can get rid of this over here, and we get that x is equal to 15. And we're done.